Good day, students. On this clip, we're going to be going over some questions to get you ready for the upcoming test. So let's start by looking at station one. We're going to do problem number two. For problem two, we're asked to find the value of log base p of x, y, z. All right, so how do we approach this? Remember, anytime you have multiplication of numbers in the log world, you're basically going to be adding the logarithmic values. And anytime you have division of numbers or quotient of numbers, you're going to be subtracting the logarithmic values. So in this case, we have a product of three variables. So if I want to apply the logarithmic rules, this is going to be log base p of x plus log base p of y plus log base p of z. All right? Now that I have it all broken down, now I can now substitute the approximate logarithmic values here and then just add it. So this is going to be approximately, what is log base p of x? You just plug in the approximate value here, 0.3515. And then log base p of y is 0.7123. And then log base p of z is also 0.7123. All right, so all you simply do is just add them all together, and that will give you what your answer is. Okay, so let's go ahead and add it. So for this one, we're going to have 0.3515 plus 0.7123 plus 0.7123. And final answer is 1.7761. Final answer is 1.7761. All right, so that's your approximate result. Okay, let's try a problem that involves division. So let's try number 4. So for number 4, we're looking for the value of log base p of y divided by xz. Okay, so for this one, if I want to break this down, this is simply going to become log base p of y minus, parentheses, since this is a product on the bottom, log base p of x plus log base p of z. Now, since this minus affects both terms in the denominator, you have to distribute the minus to both of them. So you're going to have log base p of y minus log base p of x minus log base p of z. Now remember, you always subtract the terms in the denominator. All right? So I'll just substitute the logarithmic values and find out what it is. So log base p of y is 0.7123. Minus log base p of x is 0.3515. Minus log base p of z is 0.7123. Okay? Now, since these two are the same, they're going to cancel each other out to 0. And your final answer is negative 0.3515. All right? So just remember, everything on the bottom eventually will be minus in front of them because that's what division is. This division affects both of them, so they both eventually become minus and minus. All right? Now let's go ahead and take a look at number 16. We're asked to find the value of y equals, says solve this equation, y equals 3 log base 3 of x when y equals 6. So all we just simply do is plug in the value of y into this equation and then solve for what x is. Okay, so y is 6, so we're going to have 6 equals 3 log base 3 of x. Now how can I isolate this log so I can eliminate it? By dividing by this 3, right? So what I'll do is divide both sides by 3. So divide this by 3 and divide that by 3. And then it's going to give you 2 equals log base 3 of x. Now to get rid of this log, the base is 3, so you're going to put a big 3 on both sides. Have a big 3 on the left and a big 3 on the right. And these two terms will get exponentiated. So we have a little 2 and a little log base 3 of x. Now on the left side, 3 squared is 9. And on the right side is 3, and that log base 3 cancel out, so you have x. So your final answer is x equals 9. Okay? All right. Um, let's try number 19. So for number 19, we have the natural logarithm of y equals the natural logarithm of x plus 7. Find the value of x when y is 6, so we'll plug in the value of y here, which is 6, so I have natural logarithm of 6 equals natural logarithm of x plus 7. All right, so let's see, how do we get rid of the natural logarithms from both sides? You remember the base of natural logarithm is e, so I'm going to use e as my basis of exponentiation. So I'm going to have a big E on the left and a big E on the right, and then I'm going to have a little ln natural logarithm of 6 equals e to the little natural logarithm of x plus 7. Okay. On the left side, the e and the ln's are inverses. They cancel out, so I have 6 equals. The e and the ln cancel on the right also, x plus 7. To get 7x by itself, you subtract 7 from both sides. And then you end up with x equals -1. And there goes your final result. Okay. All right. Let's move on to question number 1 on station 2. Okay, I'll make this a little bit smaller. So on station 2, question 1, it says, how many ways can 7 unique diamonds be arranged in a circular bracelet? So for that one, we have a circular permutation type problem, okay? Because you're arranging the diamonds on the circular bracelet. You have 7 of them. 1, 2, 3, 4, 5, 6, 7. So you have 7 of them. How many ways can they be arranged in the bracelet? This is a circular permutation type problem. Okay, so we're going to use the formula n minus 1 factorial because one of them has to stay fixed, and then the others, you get to move them around. All right, so to do this, you're going to use n minus 1 factorial. How many bracelets, diamonds are you arranging? N is 7. So the answer is going to be 7 minus 1 factorial. 7 minus 1 factorial is going to be 8 factorial. I'm sorry, it's going to be 6 factorial. And what is the value of 6 factorial? 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. All right, so this is going to be, let's do that with a calculator. So 6 factorial is 720. All right, so your answer is going to be 720. All right, now let's move along to another problem in the same section. This is 720. We're going to take a look at question number 3. It says, how many ways can the letters of the word palladium be arranged? So for this one, we're looking at alphabetical permutation here. All right, so for number 3, we're looking at the word palladium. Palladium. So for alphabetical permutation, you're just going to have total factorial divided by your repeats factorial, right? So how many letters do we have in all? In palladium, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 in all, 9 factorial. Any repetitions? P does not repeat. We have 2 A's. So we have 2 A's. And then we have 2 L's. 2 L's. And then what else? 2 A's, 2 L's, and that's basically it. So we're going to divide 9 factorial by 2 factorial for the A's that repeat, and then the L's that repeat, we are going to divide by 2 factorial. All right, so there you have it. So I'm going to leave it like this. This expression is good enough for this lesson. Okay, so 9 factorial divided by 2 factorial, 2 factorial. That's good enough. All right. Now, moving along, let's take a look at number number 7. So for number 7, let's take a look at what it says. Number 7 says that the team comprising of 5 men and 6 women are to be selected from a pool of 10 men and 12 women. Um, what is the total number of ways that this can be done? So since these men and women are just being selected without any order, so since there's no order, it's going to be combination. Okay? If they are being selected to fill specific spots, then it will be permutation because order will be important there. So we're going to be using combination. Okay, so for the men, we're going to have out of the 10 men, we're selecting, remember choose for C, we're choosing 5. And then for the women, out of the 12 women, we're choosing 6. All right, so the total, since we're having men and women, remember the operation for and is multiply, right? So for men is 10, choose 5, and is multiplied by 12, choose 6. And there goes your final answer. All right, so there you have it. Okay, now let's move along to station 3. And we're going to work on some problems concerning discrete mathematics. All right, so let's start out with number 1. So for number 1, we're to find the sum of all even numbers between 3 and 79. So all even numbers between 3 and 79 we're going to start from 4. What's the next even number? 6. And it goes all the way to 78. Okay? All right, so since it says sum, we have 2 choices for sum. Is it geometric or arithmetic? Since we're adding every time, for even numbers, we're always adding 2. So for this one, it's going to be arithmetic, right? So we're going to use the sum formula Sn equals n over 2 times a1 plus an. Okay? So let's see what we have. The first term a1 is 4. The last term an is 678. How many numbers are there from 4 to 78? How many even numbers? I have no idea, so let's figure this out. So we're going to call on the other formula to help us out. The other formula is an. The other formula for arithmetic, which is the nth term, an equals a1 plus n minus 1d. All right, so let's use it. So an, the last term is 78, so we're going to have 78 equals, the first term is 4 plus n, we do not know, minus 1. D is you add 2 every time, so it's going to be positive 2. So if we solve this for n, we just plug it here and find what the sum is, okay? So we can subtract 4 from both sides. And while we add it, we can distribute the 2 to these 2 terms right here. Okay? So 78 minus 4 is 74. 74 equals 2n minus 2. So we're going to add 2 to both sides. Add 2. Add 2. And then we're going to have 76 equals 2n. Divide both sides by 2. And then 2 goes into 7. We have 3. 38 equals n. So n is 38. Are we done? Absolutely no. We need to find what the sum is. So the sum, S38, is going to be n over 2, which is 38 over 2, times a1, which is 4, plus an, which is 78. Okay? 38 over 2 is 19 times 78 plus 4 is 82. All right, so we can just work out what that result is. So we have 19 times 82, and your final answer is 1558. So your result is 1558. Okay, 1558. So remember that anytime one formula doesn't suffice, you might have to call on the other formula within the same set of whether it's arithmetic or geometric, in order to find out in order to find a missing term, and then you find your final result. All right? Okay. All right, let's move on to question number 5. These problems involve involve infinite series, because anytime you have the dot dot dots, those dot dot dots basically mean that, so these dot dot dots, it means that the series goes on forever. So number 5, we're asked to find the nth term. So we're going to use the nth term formula for geometric series, which is this right here. So the nth term formula I'm going to use is an equals a1 times r to the n minus 1. Okay, so to do this, number 5, we have 1 plus 3 plus 9 plus 27 plus dot dot dot. So the common ratio, the first term a1 is 1. The common ratio r, you just divide the second term by the first term, right? a2 over a1. So you just simply do 3 over 1. What's 3 over 1? 3. Okay. So to find the n term, a sub n will simply be 1 times the common ratio, which is 3, to the n minus 1. And now you can simplify for it to an equals 3 to the n minus 1. And there goes the formula for the nth term of your geometric series. All right. Okay, now let's move on to question number 11. From the question 11, we're asked to find the sum of the following infinite series. So we're going to have sigma sum from n equals 1 to infinity of 3 times 1/3 to the n. Now first we have to test for convergence, right? So the question is a common ratio between -1 and 1? If it's not, then we cannot find the sum. All right, so this is going to infinity. So a1, the first term a1 you get by plugging in 1 into the equation. So I'm going to plug in the lower limits. That's where you're starting from, this 1. I'm going to plug it into there to find what a1 is, okay? So let's work it out. So a1 is going to be 3 times 1 over 3 to the first power, which is 3 times 1/3. Final answer is 3 over 3, which is 1. That's a1. All right, and the common ratio is whatever is being exponentiated. So the common ratio is 1/3. So 1/3 is between -1 and 1, right? It is between -1 and 1. So the series is convergent and the sum exists. Okay. So since the series is convergent and the sum exists, we can now use the formula S infinity. This formula right here, infinite sum formula, equals a1 over 1 minus r. All right. So let's do it. So S infinity is going to be a1, which is 1, divided by 1 minus 1/3. So you're going to have 1 over 1 minus 1 over 3. So you times this by 3 top and bottom, and your answer, and then your answer is going to be 1 over 3 over 3 minus 1 over 3, which is 1 over 3 over 3 minus 1 over 3 is 2/3. All right, so this one, to do this, you just drop, change, flip, drop the top to 1, change the times, and then flip the bottom to 3 over 2. Multiply across, your final answer will be 3 over 2. Okay, so there you have it. All right, now let's move on to station 4 problems. Let's take a look at question number 1. It says, convert the following into radian, and then graph it and determine what quadrant it lies on. So for number 11, oh no, for number 1, we are dealing with the question 11 pi over 4. 11 pi over 4. So how do we change this to radian? I mean to degree. Do we multiply by pi over 180 or 180 over pi? Since pi is on top, we're going to multiply by the one that cancels this. So we need the one with pi on the bottom, pi over 180 over pi. Okay? All right, so your final answer is going to become, the pi's cancel out, which is degrees. So you're going to have 11 times 180, 180, which is going to be 1980 divided by 4. All right, and then if you divide that, you can divide out with your calculator. 4 goes here, 4. carry 3 and goes into 38 9 times. Carry 2, 495, 495 degrees. Let me just verify with my calculator real quick. 1980 divided by 4, 495. Okay, so there you have it. Okay, so where on earth is 495? Let's go ahead and graph that real quick, and then determine what quadrant it lies in. Okay, so where is 495 degrees? So starting from 0, uh, since it's positive, we're going to go up, right? Up and around. So 0, 90, 180, 270, 360. Keep going. Add 90 to that, 450. Keep going. Add 90 to that, 540. Stop. We already went too far. So our terminal side is going to be somewhere between 450 and 540, which is right here. Okay? So to indicate the direction we did to get there, we went one full spiral, which is 360, and then bam. There goes their final result. This is the terminal side, and this is 495 degrees. And our result is in quadrant 2. Okay? All right, so there you have it. Okay, so last but not the least, let's take a look at number 9. We want to convert 300 degrees into radians. So for number 9, how do you convert 300 degrees to radian? All you do is you multiply by pi over 180 degrees because you want the degrees to cancel. So this degrees cancel. So you're going to have 300 pi divided by 180. All right? But of course, you can reduce this. The zeros cancel out by dividing by 10. And then you have 30 pi over 18. And we know that 6 goes into, we can just divide by 6, top and bottom. So we're going to have 5 pi over 3. And there is your final result. Okay? So there you have it. All right, thanks for paying attention to this presentation. Remember that all these videos are online. You can subscribe, and more videos at mathgotserved.com. That's the quickest way to access all my videos. All right, so have a wonderful day.